Okay, if you didn't copy these problems exactly with detail and neatly, please go back and do that first. It's really not going to make a lot of sense unless you're able to really interact with these pictures. All right, so number 5. I want to find the measure of the angle or the arc indicated. So in this case, we're looking for the measure of angle CAB. That's where the question mark is, and that's an inscribed angle. So if I were to cut out that inscribed angle, it would come with this arc. That is the intercepted arc for that angle. And we know that the intercepted arc is equal to 2 times the inscribed angle. So if I look at the intercepted arc's measure, that's 170. So that's equal to 2 times the measure of angle A, which is the inscribed angle, angle A. All right, so if I divide both sides of this equation by 2, then I get 100, just kidding, 85 equals the measure of angle A. So this is 85, half of 170. All right, you might think that setting up that equation isn't necessary, but as usual, the problems are going to get more complex, so it's a good practice to start setting up the equations. Okay, the intercepted arc is equal to 2 times the inscribed angle. All right, so for number 6, I want to find this question mark angle, so I'm going to actually trace that angle. So this is the angle that we're looking at trying to find. By tracing that angle, it makes it easier to identify the intercepted arc because I've already traced the endpoints of that arc. So that would be from B to C. That is the intercepted arc for that angle. So 94 equals 2 times the measure of angle D. So if I divide both sides by 2, I get 47 equals the measure of angle D. So this right here is 47 degrees. Number 7, okay, I would like to know this arc measure. The inscribed angle that intercepts that arc is right here. So the arc measure is equal to 2 times the inscribed angle. So that's 2 times 35. So the angle is, the arc is 70 degrees. So this is 70 degrees right here. Let's look at number 8. All right, I need to know this arc measure. If I look at the endpoints, I can find the angle that inscribes that is intercepts that is the inscribed angle. So by the formula, the intercepted arc is equal to 2 times the inscribed angle's measure. So the measure of xy is 120. Number 9. All right, this time it's not going to be as straightforward because I'm looking for this angle measurement right here, and the problem is I don't know the measure of the intercepted arc. So I'm going to have to do a little work to find the measure of that intercepted arc. But what I can notice is that if I add the measure of GF to the rest of the arcs, so that would be 122 and then 50 down here, I will have gone all the way around the circle. So I could say that equals 360 degrees. All right, so if I subtract 50 and 122 from 360, then I'm left with 188. So the measure of GF is 188. And then our formula says that the arc is equal to 2 times the inscribed angle's measure. So 2 times the measure of angle E. Well, if I divide 188 by 2, I get the measure of angle E is 94. So this is 94 right here. So sometimes you might have to do a little bit of work to find either the inscribed angle or the intercepted arc before you could use this formula right here. Okay, let's look at number 10. So with number 10, I have a 54-degree angle right here. It's always helpful to go ahead and highlight the measurement that you have, because that allows us to find the intercepted arc measure. So that intercepted arc is just double the inscribed angle, right? The intercepted arc is double the inscribed angle. So this is 108 degrees right here. Well, that's helpful because the next thing you might notice, yes, we're looking for ML, and there's a diameter in this picture. A diameter cuts off 180 degrees. So these two arcs right here, ML and KL, add up to 180 degrees. So the measure of, ML added to KL, which is 108, equals 180 degrees. So finally we know the measure of arc ML is 72 degrees. So this is 72 right here. All right, number 11. All right, now we need to set up an equation to solve for x. So 35 is this inscribed angle right here, and EF is the intercepted arc. Again, the formula is that the intercepted arc is equal to 2 times the inscribed angle. So the intercepted arc, which is given to us as x plus 70, equals 2 times the inscribed angle is 35. So it says x plus 70 equals 70, so x must be 0. All right, let's set up for x and solve another one. All right, this one looks a little bit more complex, but if you get those highlighters out and you start highlighting arcs and angles, it's going to make it a lot easier for you. So I'm going to highlight the 51-degree angle. So that's where I started. And the reason I would do that is because then I can identify the arc that goes with that 51-degree inscribed angle. All right, the arc is 2 times the inscribed angle. So this is 102 degrees. Again, I can go back to diameters in this problem because I have a diameter right here, FH, and a diameter cuts off half a circle, or 180 degrees. So these two arcs together have a sum of 180 degrees. So my equation to solve for x will be 5x and 13 added to 102 equals 180 degrees. So that's 5x plus 115 equals 180. Subtract 115. I get 5x equals 65. Divide by 5. X is 13. Okay, go ahead and get started on your practice set for the remainder of the period.